Good afternoon, all. Am I audible? Hello.
Audible, madam. Audible.
Okay. So we are going to start our session. Just wait 1 minute, then we will start.
Madam, sorry to disturb you, but I will ask one question. If it is possible, you can guide me, madam. For any time constant calculations, any fixed procedure, or simply we can find RC circuit RC, LR circuit L by R like that. For
Uh,
different combinations of R and C's.
you're talking about, can you repeat again?
Yes, madam. Suppose, let us say, input is applied at the R1 in series with the C1. Output is taking across the parallel combination of R2. Then the time
Okay.
constant is R1 plus R2 multiplied by C.
Hmm.
Suppose one R1 is there and R2 parallel with C is there. Then the time constant is R1 parallel R2 multiplied by C.
Hmm.
Suppose like that, R1 and C1 is parallel combination. We are applying input through R1 C1 parallel combination, and we are taking output across R2 C2 parallel combination. When the time constant, how it will be like that? Any procedure is there? Sometimes series, sometimes parallel.
Okay. We will try this type. We will solve this type of problem in the next station also. Okay.
Okay, okay. Thank you. Thank
Okay. You can also write this type of issue, na, which whatever you want that in the next session it will discuss. You
you.
can
Okay.
mail me direct. Then this type of 2 3 problems I will solve in the session.
Yeah, yeah. Thank you.
Okay.
Definitely. Definitely. Yeah.
So you can directly mail your question to me, and in the next session I will try to solve 1 or 2 problem. Okay.
Definitely,
Be-
definitely.
because the question is also how your want like how the resistance or the capacitor I think is in parallel circuit, and then you have to calculate the time.
Okay.
So it is better than you can directly mail me. So in the next session I will discuss it.
Okay, ma'am. Definitely.
Okay.
Your mail ID is in the PPT,
um
madam.
just it is biswas.5@iitj.ac.in.
Yeah, one minute,
Okay.
madam. Please
Just
let
a
me.
minute, I am writing in the chat box.
Okay, okay.
Okay. Just give me a minute. uh, you can get my mail ID in the chat box, so you can directly mail your problem.
Okay.
Okay. Okay, so let's start the session. This is week 7 problem solving microelectronics device to circuit session. I'm Arpita Biswas, a PhD scholar in electrical engineering department from IIT Jodhpur. And this is more details about me, that I did my MTech from Triple IT Jabalpur in micro nanoelectronics, and I did my BTech from West Bengal University of Technology in electronics and communication engineering. And this class schedule is every Tuesday 7 to 9 p.m. So we are moving towards our first question. Identify the following configuration of the differential amplifier. So first option is the single input balance output. Second option is the dual input balance output. And the third option is the dual input unbalanced output. And the fourth option is the none of the above. So take your time and try to give the answer.
Single input, single input balanced output, madam. Single input balanced output.
Okay. There's one more student. Srikant, what is the right option? Please unmute yourself. Srikant. Pradeep, can you little bit explain why it is single input balance output?
Yes, ma'am. Yes, ma'am. Generally, we are giving input at the base point. One input is VN1, another input is grounded. That is single input. We are taking output between the two collectors,
Mhm.
collector 1 of first transistor and collector 2. So let us assume collector 1 potential VC1, that is VC2. Let us maybe assume VC1 more positive than VC2. So we are taking between two collectors. That's why it is balanced out.
Yes, and we are taking the input in this that side, na? We input
Yes,
one.
yes,
Yes,
yes.
that's why it is single input and balance output. So the right option is the first option. Uh, all of you, please unmute yourself and try to give the answer. At least try, and then we will discuss. Srikant. This is the question number 2. Identify the following amplifier. The first option is the Johnson amplifier. Second option is the Cascade amplifier. The third option is the Cascode amplifier. And the option D is none of the above. So please go through the structure carefully, the circuit, and try to give the answer.
Cascode amplifier, madam. Common emitter and the load is common base. CE-CB combination is cascode amplifier.
Okay. Srikant, what is the right answer? Just see the position of this T2 and T1 transistor. This T1, because T2 transistor, this T2 transistor is vertically stacked one top of the transistor T1. So it is a cascode amplifier. So is this question clear, all of you?
Yeah,
Srikant,
clear,
please
ma'am.
unmute
Clear.
yourself. So can you move toward the next question?
Yes, ma'am. Yes, ma'am.
Okay. The gain bandwidth product of the JFET amplifier is low with respect to the BJT amplifier. Is the given statement is true or false? Take your time and then try to give the answer. The gain bandwidth product of the JFET amplifier is low with respect to the BJT amplifier.
It is true.
Can you explain a little bit? What do you know about this gain bandwidth product something?
Madam, it's true statement, but BJT is suffering with minority carrier storage effect, whereas FET is does not suffering with minority carrier storage.
Yes.
But I want something more elaboration. I will listen from you, madam. Thank you.
Okay. Surajit?
Yeah, actually in JFET, there basically in BJT we are facing like minority carrier charge configuration is there, and the
Hmm.
gain is comparatively high, like the midband gain. So with respect to that, we can say that if you plot the polar plot means the Bode plot of the frequency response of the gain BJT. It is a minus 20 with slope is there. So during that region is like gain bandwidth product is constant. Gain and bandwidth is the multiplication is constant. Like for and the unity gain frequency is fixed for a BJT. But
Mm.
JFET we generally don't use for an amplifier purpose. Like we can use it like an purely resistive circuit and so on. But still it's noisy device. So the gain thing is not like that you can get from that. So from that I
Yes.
am thinking.
Yes, this statement is true. That's why we are going for the not the JFET amplifier, and we are go for the BJT amplifier. And the statement is also true. I think this statement is sufficient to elaborate this. So this is the question number 4. Identify the following structure. The first option is the junction field effect transistor. The second option is the negative capacitance field effect transistor. Third is the tunnel field effect transistor, and fourth one is none of the above.
That's JFET.
It's JFET, madam. It's JFET.
Okay.
Only two adjacent side junction with the N-type bar. So there is a single gate junction, both sides, and we are applying drain and source, negative bar.
Okay. Any of it? Srikant, please unmute yourself. At least try to give the answer. Okay. So the right option is the first one, so junction field effect transistor. This is the question number 5. The given figure illustrates dual input balance output differential amplifier configuration. Assuming the silicon transistor with HI equal to 2.8 kilo ohm, calculate the differential gain. First option 152, second is 162, third 192, and the fourth option is 172.
Can you zoom it this circuit please?
I think this is the
Hello.
maximum. Just a minute. It is not visible. Okay, I'm trying. But
Image you can drag it, madam, and then yes, then you can project, madam.
yes, now can you see?
Yes, 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 ma'am.
Oh, okay. Just put the differential gain formula and then put on. Sorry, just rem remember the key. Tell me what is the formula to calculate the differential gain, AID. Just you have to remember the formula. Pradeep, at least try.
Actually, I forgot in the formula AD in terms of HFE. I'm thinking.
Mhm. Take your time. There is no hurry. You can try at least.
Yes, ma'am.
Okay.
Mm, there will be the base resistance is there, so some voltage division will be there, due to Rin, and that I think it is 100 ohm. R6, yes. And Rin is 2 into 1 plus beta times R pi plus Re. Right. and GMRC minus GMRC times that thing. So it's coming around.
What is the value of Rin? Here Rin is given. See the structure carefully. Rin is given, HIE is given, and also HFE is given, and the value of RC is also given. Just you have to put the equation and just
Now, Rin you have to find, na? Rin
Rin is
like
given
2
now.
into.
Here, see V in one, and then the R in equal to 100 ohm is given.
No, that is the source resistance. Like, but Rin looking from the emitter base side of the NPN time. That thing is 2 into 1 plus beta into R5 plus RE.
Okay, whatever you think, just calculate it and then tell me the answer. Because in one
Okay.
problem you can solve in many way. There is no not that we are thinking we are going from this side, so only this type of problem, this type of way we are solving the problem. No, every time there is 2 3 way, so we can find out the calculation. Just tell me the right answer.
Madam, HFE into RC by 2 into RC plus HIE formula
No, the formula is HFE
into RC
into RC
by
by
2
RA
into
By Rin.
RN,
RE
RN
plus
plus
HIE.
HIE.
Okay, just put the value of RA. Here RN you can directly put the value, this one I
100
think
ohms.
100. Yes, and just tell me the right answer.
No, but here Rin is not 100 ohm. Rin is the input impedance looking from the base side. So that will be for differential phase is 2 into 1 plus beta times R pi if RE is not there. If RE is there, then it will be 2 into 1 plus beta times that RE. That is the iron. No? 100 ohm is the for that is for signal, means the for source resistance. No?
Pradeep?
Madam, it is 162 like that. Calculations are not matching. That's why I'm thinking.
Yes, the value is 162. Surely you can recheck it. And in that, if you are taking something RN, you are calculating from beta, then tell me what is the value of it. And when you are going to calculate the differential gain, in that condition, what when you are applying this RN value, what is the answer is coming. Okay.
Okay.
Because here is the simple way, just AID equal to the HFE into RC by RN plus HIE. The given value RN is given here, so you can directly put the value of RN, which is 100, and HIE value is given here 2.8 into 10 to the power 3, and the RC value is also given 4.7. You can recheck it, 10 to the power 3. And HFE value is, what is the value of HFE? I think 100. Yes, here it is given. So if you are calculating, then the value of gain is 162. Then the next question is the value of PSRR and CMRR for ideal op-amp are respectively. The first option is 0 and infinity, and the second option is 1 and 0. Third option is 0 and 0. And the fourth option is none of the above.
Option A, madam.
Okay. So the PSRR is 0 and for the ideal op-amp, and CMRR is infinite. The question number 7 is the op-amp voltage follower circuit is also known as first one buffer, second one the unity gain follower, the third option is the both buffer as well as the unity gain follower, and the option D is none of the above.
Option C, madam. Buffer and as well as unity gain.
Option C, both buffer as well as unit to gain follower.
Okay, good. This is the question number 8. What is the SI unit of the slew rate? The first option is volt per microsecond, Second option is the volt per farad. Third option is volt per volt. And fourth option is none of the above.
A, volts per
Option A,
microsecond.
volt per microsecond.
Okay. Question number 9. A statement, the given topology is a two-stage NMOS input CMOS op-amp. So is the given statement true or false? See the circuit carefully and go through the statement. The given topology is a two-stage NMOS input CMOS op-amp. Is the given statement true or false?
True, madam.
False.
True,
True,
madam.
true.
True,
Answer
madam.
is true. Because I see NMOS on the top.
Not like, and maybe that is the one reason. Another reason is between first stage and second stage there is a compensating capacitor and the current source from the first stage and differential amplifier and followed by the second stage. It's a true, madam.
It is true or false?
True, true.
No. Anyone else was there? Shurajit, what is the right answer?
It's false actually.
Can you
Because
explain?
the first stage is the differential amplifier and the current circuit is there, which is driving the current for the differential thing. And that is the, if we take the op-amp, so first stage the op-amp will be balanced input, balanced output. But
Hmm.
for the first stage we are taking the unbalanced output because we are taking output from the only single side. So, and that output is derived to the second stage. That is also like export kind of thing. So that is not a proper op-amp, internal op-amp diagram match with this.
Yes, the right option is false. And the explanation, just it is only PMOS. Okay. So the topology is a two-stage PMOS input CMOS op-amp. Good. This is the question number 10. The given figure illustrates dual input balance output differential amplifier configuration. Assuming the silicon transistor with HIE is 2.8 kilo ohm, calculate the common mode gain. So first option is 0.3414, second option is 0.2414, the third option is 0.1414, the fourth option is 0.1434. Take your time and
It option A.
question number 10. Yes, it is 0.3414.
Madam, you need to show me the formula for this.
Okay, just at least try, then I will share the formula. Okay. Pradeep, have you any idea how to calculate the common mode
Yes,
gain?
madam. Formula maybe minus HFE RC by some 2 2RE multiplied by some 1 plus HFE like
Hmm.
that.
Yes, yes. This is the formula. At least try, then I will share the formula.
Is that formula is approximately RC by 2 RE. From that I calculating. It's approximate version.
Okay, wait for just 1 2 minutes. Then we will going to solve.
Okay.
Srikanth.
Yes, madam. I am seeing the formulas. I am waiting for if there is a possibility of getting one of them, fine with me. But until then, I am trying.
Okay, okay, try. Take your time. When you are not talking, na, in that case, you can mute yourself because there is so much noises coming. Pradeep? Hello?
Substitute. Yes, madam. This is the formula.
Yes. Now calculate. Just put the value of the HFE. Tell me what is the value of HFE. It is given
8K, madam. No, no.
HFE.
100.
It is 100. Then what is the value of RC? 4.7 into 10 to the power 3. Twice of RE. What is the value of RE?
6.8K.
6.8 into 10 to the power 3.
Lashama,
Then
పెరుగుతుంది.
HIE
100.
100 plus RE 100 plus
HIE
HIE
actually 2.8K.
2.8 into 10 to the power 3.
Hello.
Yes.
The HIE is 2.8K, na? In the bracket. So write 1 plus.
Okay. What is the actually we have to zoom.
2,900. It will become 2.9. 4.
0.3421 it's coming.
12.4. 12.4 plus
HIE is given, which is 2.8 into 10 to the power 3. Okay. And
Yes.
I have
So
written,
so the
no,
formula
I
you
have
write,
taken,
na? For the
actually, I think it is HFE. Okay, it is
HFE
HFE.
is 100.
Yes,
Yes.
it is HFE.
Yeah. So the formula you have right, na? That is in the denominator part. I think it is 2RE 1 plus beta plus RIN plus RC, right?
It is
You
H.
write once.
Just a minute. HFE, then RC by twice of RE, 1 plus HFE, I think. Yes, 1 plus
Yes,
HFE.
HFE
HFE. And plus RN plus HIE.
plus HI. Yes.
Yes, now calculated. HFE value is 100. Then RC is 4.7 into 10 to the power 3. Then twice of RE, 6.8 into 10 to the power 3. Then 1 plus HFE is 100 plus 100 plus 2.8 into 10 to the power 3.
is it
Coming,
2 plus?
it is coming 0.3421.
Okay, Srikanth, have you calculated?
I'm calculating, madam.
Okay, calculate. And Pradeep?
100
So for
into
this formula, the like 2RE into 1 plus beta, that term is much higher than with compared to RIN plus HI, na? So if we neglect that thing, so approximate we can 1 plus HFE also is equal to HFE. So you can approximate like almost RC by 2RE. Is that approximation is good?
Okay, and both cases, I think the answer is coming uh, near about this
Yes, yes, yes.
0.3414.
Both cases it is coming. Yeah.
Yes. If it is very, very larger
0.3.
than the other part, then you can neglect it. Yes, Pradeep, have you calculated? And one more student,
Yes,
I
madam.
think
Yes,
I
madam.
don't
Yes,
know
madam.
your name. A211265.
Yeah, ma'am.
Have you calculated?
Ma'am, actually, I'm not aware of this formula, ma'am.
Okay, okay, no issue. Srikanta, Pradeep, please calculate and give the exact answer.
Yes, madam. 12.4 into 101. Plus 2.9
Simply just multiple this portion and then the second bracket is there and add these things.
Madam, answer is 0.3823.
0.38,
Yes, madam.
0.38.
Yes, madam.
No, it's actually coming 0.34216.
And what Shuri is saying 0.34216.
34216.
Okay, recheck your answer. We are going to wait for 1 minute, then we will go for the next question.
Yes. 100
Just check your calculation.
plus 100 and 1 is 2,800 plus 100 is 2,900. 100 into 4.7. Okay. 100 into 4.7 divided by 2 into 6.816 12.67
I think
0.6.
we go for the next. It will take more time.
Mm, just wait for because this class is for all of you now, and there is 2 hours.
12.6.
I know all of the some of you are better student, like you are gone through some of this, so it is easy for you to solve. But we have to but this class is for all of you, not for one two student. So just wait for them also.
Madam, I will Correct my answer. My answer, I think I'm getting 0.3684 after rechecking.
0.36.
Yes, madam. 0.3684.
Okay. So I have to calculate it, or is it okay to move towards the next question?
Please move to the next question.
Okay. And this is good. You have at least tried. So this is the question number 11. If AFT is the total bandpass gain, FL is the low cutoff frequency. Now we are going to solve some of the MCQ type of question. Then we will last 3-4 question we will solve the numericals. Okay. So this if the AFT is the total bandpass gain and FL is the low cutoff frequency, FH is the high cutoff frequency, then voltage gain magnitude of a bandpass filter is given by. So go through the option carefully and tell me the right answer. And there is no hurry.
Option
You take your time.
option 3, madam.
Okay. So you have remembered the equation.
From RC circuit, I have tried and I remembered and I directly.
Can you little bit explain about what
Yes,
do you
madam.
know about it?
Yes, madam. Yes, madam. If
Because
you
it
take
is
RC,
not only useful for your case,
yeah,
for those students who are not aware of this question, na? So
yeah,
when you are discussing in this session, they are also knowing, yes, this is the explanation.
yes, ma'am. Yes, ma'am.
Okay.
If you take simply RC low pass circuit, we are giving through our resistance input, we are taking output across the capacitor. So if you place V naught is equal to V in into 1 by j omega c by R plus 1 by j omega c. J omega c, j omega c get cancelled each other. You are simply getting 1 plus 1 by 1 plus j omega RC. Omega, if you place 2 pi f, like that, there is no denominator. Like that, madam. For I pass as I calculate, both the things are multiplying and you are getting it. I pass
Okay.
followed by low pass is nothing but band pass, madam.
Now I'm drawing some circuit. Can
Yeah,
you
yes.
tell? Okay. Now tell me the filter type. It is high pass or low pass?
This is I pass
Low pass.
followed by low pass.
Yes, this is high pass followed by low pass. I'm just drawing it for your basic understanding. And it is, what is the type of 0 dB?
Low pass, madam. Low
Low.
pass.
This is
Low
low
pass.
pass. Okay. And for the band pass, how it look like?
Just flat.
Yes.
Yes.
Middle flat, 3 dB frequencies, FL and F.
Okay. And the voltage gain magnitude of the band pass filter is the option 3. V output by V in is equal to the AAF, F by FL. Now, can anyone tell what is the F here?
Which one you want, madam? F,
Small f is indicating
Input
what?
frequency, ma'am. Input frequency.
Input frequency or operating frequency?
operating frequency.
It is operating
Operating
frequency.
system.
Yes. In which frequency we are operating. Okay. So next move towards the next question. So this is also a MCQ question. Effect of cascading several amplifier stages is to first option is reduce the overall gain, the second option is reduce the overall frequency response, the third option is increase the overall gain and reduce the frequency response, and the fourth option is decrease the overall gain and increase the frequency response.
Option 3, madam.
Option 3,
Increase the
ma'am.
Option three,
overall
madam.
rate and reduce the frequency response.
Okay,
Cascade.
so increase the overall gain and reduce the frequency response.
Correct.
This is the question number 13. A true amplifier has a peak output at 9 megahertz and the quality factor of 90. What is the bandwidth of the tuned amplifier? Do you know about the relation between this peak output and the quality factor?
Madam, F is
Like
equal to
band,
BW by Q.
uh,
Q is equal to FR by bandwidth, madam. You are asking for the
yes,
bandwidth.
yes, there is,
So bandwidth is equal to FR by quality factor.
yes, yes, FO by quality factor. And what is FO here?
9 megahertz. 9 into 10 power
No,
6.
it is indicating which frequency.
Oh, sorry. Okay, tuned 9 megahertz.
Like it is resonance frequency.
Yes, madam.
And this is quality factor.
0.1 mega. That is 100
100.
kilo hertz. 100 kilohertz.
100 kilo is
Yes,
the answer.
10 to the power 6 hertz, and quality
Fine.
factor is 90. So it is 10 to the power 5.
Yes, madam.
So it is 100 kilohertz. So the right option is option B, 2. So this is the question number 14. What is the output of the differential amplifier in ideal condition? First option is V output equal to AD into V input minus V input plus minus V input minus. The second option is V output equal to AD into V input plus minus V input minus by 2. Or the third option is V output equal to AD into V input plus, or the fourth option is V output equal to AD into V minus V in minus.
Option 1, madam.
Madam,
AD
option
into
3.
B. No, madam. Okay, from my side, option A, madam.
Option
Yes,
2, ma'am.
who is telling that option 2? Can you little bit explain? When we are calculating for the differential amplifier, then how we will calculate the gain?
Can I explain, madam?
Yes, explain please.
Yes, madam.
Gain
For
is
a
equal
different,
to the difference of voltages between two amplifiers divided by average of them. The
when we are
number.
going for common mode, we are taking average, madam. Otherwise, it is a differential means AD multiplied by
Yes,
V in plus minus V in minus.
yes. When it is in common mode, now in that case it is divided by 2. But
Yes,
when
ma'am.
it is only for the differential amplifier and also it is for the ideal condition, na, then AD equal to V output by the difference. Okay. So this is the little
Yes,
small
madam.
things. Okay.
Yes, ma'am.
So the first option is the right option. This is the question number 15. Common mode gain should be dash in differential amplifier. High,
Low,
low,
ma'am.
increased or moderate.
Low.
Low,
Hi,
ma'am.
madam. Hi, madam.
Can you explain, Pradeep?
Yes, madam. Generally, common mode gain should be high to eliminate the low frequency hum noise at 40 Hz. So that's why it should be high, madam.
Yes, very good. This is high. The common mode gain should be gain always be high. Okay. So right option
Ma'am,
is
ma'am,
yes.
in order to increase the CMRR value, the common mode gain should be very low.
That is what
Uh,
I thought, madam.
Pradeep.
Hello.
Yes.
Differential amplifier is suffering with the low frequency hum noise, madam. So
Yes.
to get the more rejection of the common mode at low frequency, common
Hmm.
mode gain must be high, madam.
Yes, this is the proper explanation that common mode gain should be high. Okay.
Ma'am, to get common mode should be high and means in terms of CMRR value, in order to increase the value of CMRR, the value of common mode gain should be very less, ma'am.
But
Because
in that
the differential mode to the common mode, if the common mode signal becomes zero, then we get the CMRR value is infinity,
No,
ma'am.
no, not like that, sir. Not like, okay, madam, you explain.
no, your explanation is right. So that's why I'm not explaining it. You can again explain because I'm agree with you,
Yeah, yeah.
Pradeep.
Listen, student. He is my student only, madam. Yeah.
Okay.
Actually, when you are going for CMRR, AD by AC tends to be zero. That doesn't mean that AC is nothing but common mode output to the common mode input voltage. That indicates that to eliminate the noise, common mode related should be the zero. Like that only we are explaining. Okay. To eliminate the noise, mode gain must be high to reach the goal, madam. To reach the goal,
The common mode gain should be
high, madam.
high or infinite. Okay. Or it should be high.
Ma'am, common mode signal getting very high means that CMRR value tends to zero, ma'am, which indicates the differential
Yes,
amplifier
yes.
is not, it is not working as a differential mode signal.
No,
Pradeep, do you have
actually, that doesn't. I think that also contradicts, madam, between explanation what the present student has told and what Pradeep sir has told. Because I understand it on a perspective of op-amps, but
yes,
I also
explain
did
it.
not know the explanation between keeping the hum noise as low as possible. Maybe Pradeep sir is quite right in this context.
Actually, I'm also agree with Pradeep sir. The common mode gain should be high in differential amplifier. So you can
Madam,
also recheck
madam,
it.
madam, madam, ACM formula you can place it, madam. There only. V not CM by VI CM, madam. So, CM must be as low as possible. So, to reach that, V naught CM must be zero, but not like that. But here, CMRR rejection should be taken place with respect to the common mode noise should be avoided, madam. For that common mode noise, here the contest is different, madam. Differential amplifier we should think.
So you can also recheck it. But I also agree with Pradeep that the answer is high. You can recheck it and we can also discuss in the next session.
Okay,
Okay.
madam.
So you can recheck it. The common mode gain should be high or low for in differential amplifier. So this is the question number 16. Calculate the op-amp CMRR when inputs AD equal to 2 and ACM is 10,000. And you have to find it in the terms of dB. Tell me what is the right answer. What is the formula for CMRR?
AD by ACM.
Yes.
20 lakh to the
And
base
what is
10,
the
2 by 100, 2 by 10,000.
so what is the value?
1.2 decibels, ma'am.
Point 30 then 2. And now tell me in the dV how to find out what is the
20 log
formula.
CMRR, ma'am.
20 lakh.
Yes,
I thought 10 log.
CMRR
1.02, ma'am.
20 log base
Sir,
10
10,
so
ma'am.
The 20 log only, sir. If it is power, 10 log.
CMRR, ma'am.
And the value of
Point
CMRR
CMRR,
is 0.0002.
0.002.
And what is the value?
1.02.
Calculate it.
1.20.
Just a minute. Carefully calculate it. What is the value of it?
Madam,
Log
I
base
thought
10.
I am getting.
Yes, tell me what is the right answer?
Madam, minus 73.97 dB.
Yes, yes, this is the right answer. Minus 70. Another student who is telling like 1 point something, please calculate it. Then we will move toward the next question.
Ma'am,
I will
Minus
repeat my
calculating
formula.
individual.
96.24, madam. Minus 96.24.
Madam, I
Just,
will tell my formula. How I got
Yeah,
minus 73.97
yes.
yeah. I also will
is
tell.
equal to 20 log times
Hmm.
0.0002.
Hmm.
That's it. That is log of base 10 we have to take. That's all.
Madam, minus 73.97, madam.
Yes, this is the right answer.
Yeah, yes, sir.
And
I'm
I
You can
think,
take not 10 logs, sir. It is a voltage related, gain related. You have to take 20 logs, sir. CMR.
Ma'am, calculating individually for taking decibels, we are getting answer from different answer, ma'am.
No.
Means calculating AD in terms of decibels and ACM in terms of decibels and dividing both of them, getting the answer 1.20, ma'am.
no, actually, this is not the right way. Here, just you have to take this formula that CMRR equal to 20 log base 10, then AD by ACM. Okay, CM. Just took this formula. Just put the value here. There is 2, and this is 10,000. For the equation, like making this easy, that's why I am directly put here. Now calculate that. Recheck your answer, then we will move toward the next question. Take
Ma'am,
your
the answer
time.
that I have checked it is right only, ma'am, but converting of individually into decibels, we think it's wrong, ma'am.
So then you can
Means,
do it to 20 log to the base 10 AD
Then
minus
the
20 log to the
yes,
base 10,
you know that
10,000. You
formula,
can
na?
do it. Definitely will get minus
uh,
7.
Log of A1 by A2. How we can write individually? Tell me.
log
Log
A1
of
minus
A1
log B.
minus log of A2.
20,
Yes. So if
20 multiplied.
it is here, it is also 20 multiply.
Multiply.
Yes. So
Yes,
just
ma'am.
take this value and it is multiplied with
And
20.
definitely you will get minus 73.9.
Recheck it.
Yes, ma'am, I got the answer, ma'am.
Yes.
Let's continue the next question.
Nice.
Okay. So this is the question number 17. What are the advantages of multi-stage amplifier? The first option is improvement in gain. The second option is we will get improved Q point. The third option is we will get improved in input and output impedance. Or the fourth option is all of the above.
All of the above. All of the above.
But madam, there is a contradiction from my side. How Q point is improved? Only I am choosing improvement in gain, madam. But cascading, the requirement is stage improve input impedance must be high and output impedance must be low, madam. Option A,
Yes,
madam, from
ma'am.
my side.
From my
So
side, third
Pradeep sir,
sentence.
Yeah, sir. Tell me,
actually
sir.
Pradeep sir, I have a logical point here. You see,
Okay.
cascaded amplifiers is different from multi-stage amplifiers.
Okay, sir. Okay, sir. Yeah. Like cascode and cascade both are comes under multi-stage. Correct, sir. Correct, sir.
Then in that case, what is the right answer?
Then all of the above, madam.
Yes, all of the above.
But Q point, I don't have some idea, madam. Can you elaborate that? Generally, cascade is suffering with frequency response, but whereas cascode improves in terms of the frequency response and gain. So, which point we have to apply for the second point justification, madam?
Any of you, have you any idea about the Q point?
Srikanth, sir, can you
Yes,
give?
yes. See, if you have multi-stage amplifiers, no, for example, say Darlington amplifier or
Okay.
any other Cascode amplifier, there
Okay,
you
sir.
have to use bootstrapping in order to avoid
Ah,
high impedances.
okay, sir. Okay.
So that is why if we go for differential amplifiers, you're going to take difference of two amplifiers and adjustment of gain will come to the middle of the straight line where you are having 45 degrees.
Oh, like tuned amplifier. Okay.
Yes, sir. Because you are having the ability to tune between RE, that is the resistor at the emitter side.
Okay.
So if you tune properly, no, obviously you will end up having a Q point that is exactly at the center of the straight line, which is actually downward going.
Yeah, yeah. At that place, we will get maximum gain at that particular frequency. Correct,
Yes,
sir.
sir. All of these are possible.
Correct, sir. Correct. Thank you, sir. Thank you. Understood.
Okay, good. And this is the
Ma'am,
question
will you
number
please
8.
elaborate the third option, ma'am?
Can I tell, madam?
Yes, yes.
Yeah, actually, dear student, please listen. When you are going for cascading or you want to connect one as a source, another one is a drive, there must be high input impedance and low output impedance of particular stage. Then
Yes, sir.
only more current will be driving to the second stage. So here, when you are going for multi-stage means either it may be a telescopic or cascading connection. Obviously, we will get better impedance matching for the stages. That's why the point says that improved input and output impedance, not that is increased or decreased. Improved means the performance of that input and output impedance are matching to reach the requirement.
Okay.
Okay. So this is the question number 18. The three-stage amplifier has a first stage voltage gain of 100, the second stage voltage gain of 200, and the third stage voltage gain of 400. So find the total voltage gain in dB.
100 into 200 into 400, this should be taken as 20 log of. That's all.
So tell me the answer. Calculate it, and or you can individually also.
20,000. 20,000 into 4. 80,000. 8 lakh. 80 lakh. Is equal to 20 lakh, 80 lakh. Wait, I'll tell the answer.
138 decibels, ma'am.
138 dB. Yes, the right answer is 130. So can you little bit explain how you have calculated?
38 decibel, madam. 20 log to the base 10 multiplied by 100 multiplied by 200 multiplied by 400.
Okay. And also you
Otherwise,
can individually also we can you can also find. Okay. So
find and
first stage,
multiply.
yes,
Yes, madam. 138.0617 decibel.
voltage gain in dB.
Correct.
Tell me first stage 20 log base 10 into in 100. So what is the value of it?
40, ma'am.
Okay, 40. And second stage 20 log base 10 and it is 200. What is the value of it?
46 decibels, ma'am.
46 decibel. The third 20 log base 10 200. So what is the value
52
of third?
decibels, ma'am. 52 decibels.
52.0.
52
Okay, so
decibels, ma'am.
approximately we can take the 52 decibel.
Okay.
So total voltage gain
138.
so total is 138 dB. Okay. So this is the question number 19. A multi-stage amplifier employs 5 stage each of which has a power gain of 30. What is the total gain of the amplifier in dB? And if a negative feedback of 10 dB is employed, find the resultant gain.
First one answer is 20 log 30 into 5.
Sir, please
Sir, again
calculate
10
it
lakhs, sir.
and
10 lakhs, sir.
and
10 lakhs, sir. Power gain, na?
yes, and please tell the exact value.
Yes, madam. Yes, madam.
21.7 decibels, ma'am.
No,
I'm considering it is power gain 10 log
yes,
to the base 150, ma'am.
yes.
Sorry, 10
Power
log.
gain formula in dB. Tell me what is, now. Tell me the how to calculate. 10 log
10 log.
14.77, madam.
10 into
14.77.
yes 14.777.
7.
Yes, the 10 log 10 base 30. Okay, then what is the value of it? 14.7.
14.77.
So this is for the, I think, each cases, right?
First
Yeah.
case,
Five
madam.
stage. First case, yes. A multi-stage amplifier employ five stage, each of which has power gain. So each, then here total five stages are there. So total gain, total power gain.
5 into 14.77.
Power gain 5 into 14.77.
7.
Then what is the value of it? Calculate it, please.
73.85.
73.85
8.
dB. And what is the answer of first case? And for the second case, if a negative feedback of 10 dB is employed, then find the resultant gain.
Total we have to minus it 5 into 4.77, madam.
Just total gain at first try, then I will explain or I will calculate it. Just simple the 10 a negative feedback of 10 dB is employed. Total gain you have find out. Now 10 negative feedback is employed. Then how you will find out the resultant gain? Just reduce this 10 from the 73.85. Na?
63.8.
Yes. So the resultant power gain.
But it is saying a word feedback, then people are thinking, madam, that's all. It's a reduction of 10 dB. What is the resultant?
Negative feedback 73.85 minus just 10, and you will find out the 63 point. What is the value of it? 63.85
Fine.
dB. So this is the question number 20. For the given differential amplifier circuit, assume beta of a both transistor is very high. The value of V input 2, for which the current flowing through this 2 kilo ohm resistor or transistor of transistor Q2 is 1.8 milliamps, is what is the value of it? Assume the VT is given 26 millivolt. So please try to solve the question and give it and tell me the answer. There is a given for the given differential amplifier circuit. Assume beta of both transistor is very high. So the value of V input 2, for which the current flowing through this 2 kilo ohm resistance of transistor Q2 is 1.8 milliamps. This means we have to find out the value of V input 2. In which case, where the Q2 the 2 ohm resistance, in that case, how much current is flowing from that? 1.8 milliamps. So tell me what is the value of V input? V input 2. And the condition is given beta is very high. At least try, then we will discuss.
18 twos are 36.
Which value?
Madam, 3.6 volt is flowing input Vi2, but input
Um,
V into is actually having different formula, madam.
okay, find out how we will calculate. First tell me, if beta is very large, then what is the value of alpha? Pradeep?
Alpha.
Madam, I'm not on the track. I am checking.
Okay, take your time. Then we will solve. We'll work for 2-3 minutes, then we will start to solve this question.
If beta value is very high, then alpha value must be 1.
Yes, is alpha is 1, then tell me what is the value of IC here? Alpha equal to IC by IE, right? IC by IE, right? Then if
Yes, madam.
alpha is 1, then IC value how you will calculate? It is
It's almost
equivalent.
IE.
Yes,
IC is almost IE.
yes, it is almost IE.
Yes,
And
madam.
in that case, the so we can write like, if we are taking this is 1 and this is 2, then can we write like IC1 equal to IE1 and IC2 equal to IE2? Can we write
Yes,
it?
madam.
Then tell me what is the value of VID, the differential input, I think. Can we write it? V input 1 minus V input 2. Now tell me how you will find out the value of IC2 and IC1. First tell me how to calculate the IC1, the current flowing from this and this.
Already given, no, madam. It is 1.8 milliamp.
It is all given for which case? When we are calculating the IC2, right?
Yes, madam.
IC2 is, oh, it is given. And what is the formula? So with where we can put the IC value, and if there is some formula is there, so we can find out the unknown factor. Like IC1, how we will find out? IEE by 1 plus exponentially minus VID by VT. Can you remember this equation? How to find out
Ah,
this here? The IEE by 1 plus exponentially minus, the first case it is minus, if you are taking minus VID by VT. So here IEE that one. Okay, so now tell me what is the, here we, I have to, if you are writing, please write down it, then I will erase it.
wait, madam. I will take this down. 2 milliamp divided by 1 plus e power minus VID.
And also the same way we are going to calculate for the IC2 value. And then we will put down the value we know, and we will find out the value of V input 2. Just give me some time. So the value of IC2 is IEE IEE by 1 plus exponentially VID by VT. Now we know that the IC2 value, what is the value of IC2? It is 1.8, which is given milliamps. Okay, and IEE, it is value is 2 milliamp. So we can directly buy this 2, and we can write it like 1 by 1 plus exponentially VID value. Here VID is V input 1 by minus V input 2. Okay. Now, can you
Okay.
calculate the value of VID? Because all of the value are given. VID, we know that V input 1 minus V input 2. Okay, and VT, the VT value, the thermal voltage is 26 millivolt. Just put in this equation all the value and just tell me what is the value of V input 2. At first try, then I will solve here.
But what is the value of V input 1 and V input 2? That is not given, no, madam.
V input 2 you have to find out.
Yes,
For that,
madam.
this from this 2 kilo ohm 1.8 milliamps current
Okay,
is
got
flowing,
it, got it.
and V input 1 is given, which is 1 volt. Okay,
Yes, madam. Yes, madam. Got it.
so just we have to put the formula that IC2 is equal to IE by 1 plus exponentially VID by VT. Now we know all the value, just we have to find out the V input 2. Try.
One
Take your
minus
time, there is no hurry.
1 minus x by 26 milli.
Pradeep
minus
sir?
24 millivolts.
No.
Minus 57 millivolts, ma'am.
No, not minus 57 millivolt. Please check it carefully. I'm not talking about the VID, okay? I'm talking about the V input 2 value. V into. Pradeep, have you calculated?
I'm doing, madam.
Just see. From there now, can we write 1.11 equal to
Directly you can
1
write
plus
down VID is
exponentially
equal to.
VIT by VT.
Yes, yes.
Yes. Then
This is point 0.9
exponential
na madam. 1.8 by 2.99 na. Okay.
Point 0.9, madam.
Point 0.9 madam.
uh, which one?
1.11 is
1.8
wrong.
by 2.
One, no, not 1.8. Like if you are taking this side in the upper, like you're just crossed multiplication, 1 plus exponential VID by VT. So you can write out the 2 by 1.8. Okay, just cross
Okay.
multiplication. Here
Okay.
you can
Okay.
see 1 plus exponential. Okay,
Okay. Okay. Got it.
okay. So exponential VID by VT. This value, tell me what is the value of it?
0.11.
0.11, because
Yeah.
here 1 is going this left side. So minus 1. So 1.11 minus 1. The value is 0.11. Is it okay?
Yes, madam.
Okay. So just both side you have to take
Logarithm
the
on both
ln.
sides.
Yes, ln of this exponentially vi vit by vt, and this this side also. So ln 0.11. From there you can write here vid by vt equal to, what is the value of ln 0.11? Tell me the value of ln 0.11.
Minus 2.2.
Yes, minus 2.2. Now tell me what is the value of vid. Just minus 2.2 and multiplied with 26
Minus
millivolt.
57 millivolts.
Yes, the vid equal to minus
Minus 57 volts.
57.3
Millivolts.
millivolt. So now you get the vid, which is v input 1
Minus
minus v input 2.
input
This
2.
value is minus 57
Minus
point. Yes. Hello.
minus 1 plus 57.3 milli.
Millivolt. Then this is v input 1. Value is given, na, which is 1 volt. So we can write, like if you're moving this side, v input 2, then this is 1 volt equal to 1000 millivolt, and this will move towards this side, plus 57.3 volt millivolt. Am I correct? It is matching with your answer also. Hello.
Almost.
Okay. 1057 almost millivolt. 1.057 volt. This is V input 2. This is the answer. Please check with your answer. Any doubt?
Yes, madam.
Yes. Just wait for a minute. I'm coming back in 1 minute. Hello. So have you checked this answer?
Yes, madam, it is correct.
Okay. So can you move towards the second next question, or do
Yes, yes,
you have any other doubt? This is the question number 21. For the given MOS differential pair, both MOSFET are perfectly matched and following are the device parameter for both MOSFET. VTH is given, which is 0.5 volt. Mu and COX by L is 4 milliamps per volt square, and lambda is 0. The differential gain of the amplifier is. So we have to find out the differential gain. So let us try, then we'll solve the question.
Root of mu and COX W by L ID.
Which value you are talking about?
I am talking about GM because A differential is equal to GM into RD. I know that,
Hmm.
but GM value I am seeing now is
GM
equal to
value
root of
is
mu.
root over twice of ID into mu and COX W by L.
Yes, madam.
Just here, at first tell me for the MOS differential pair, when we are going to solve it, this type of problem, then there are two parts, na? One of them is the differential and one of them is the common mode component, right?
Yes, madam.
But when you are going to solve for the small signal, in that case, which one is zero?
Common mode.
Yes, the common mode part is zero, or VCM will be zero. Like if we were adding some DC source, then in that case, this current, like from here, it will be open circuit or short
Open
circuit.
circuited.
Open
Then
circuit.
this will be open circuit. So in that point, it is acts as a virtual ground, right?
Yes,
Oh,
ma'am.
Okay. So now you are getting some clue how to solve it. And also, if you're like in that case, what will be the equivalent circuit? So just draw the equivalent circuit. If the DC voltage is applying, in that case, only the 5 kilo ohm here, and also in, can we write this is 5 kilo ohm, and also there is a 5 kilo ohm. It is in series.
okay.
Oh, sorry. and then the MOSFET is coming. The V input 1, and this is the 50 ohm resistance, and also there is a virtual ground, and this is the 50 ohm, and here the V input 2 is, so this is the M1, you can write M2 positive and the negative. So can we say it is like look like the half symmetry? Can you tell it? Can we take can we calculate for one part so it will be also for the second part? Can we take the half symmetry portion?
Madam, if there is a virtual count between the two 5Ks, no, madam, on the top
Yes,
side,
yes. Here also the virtual ground is
then
present.
it is possible to take the half symmetry.
Yes. So in that case, how it look like the circuit look like here is a 5 ohm resistance, 5 kilo ohm, I think, yes. And also here the 5 kilo ohm resistance, and then the MOSFET, and below there's a 50 ohm, yes, and then there is ground, and this is the B input 1. So now can you calculate the gain? So what is the value of AV when, so in the source there is a resistance is present, so how in that case how you will calculate the gain? So for the half symmetry, na, it is if you are calculating for the one case, it is also the same value for the second case. So AVM will be for the both cases, the AVM will be equal. So if we are taking for the half of the circuit, half symmetry of the circuit, then we can get the answer also, the mod of AV. So just tell me if it is a like it's behave like a common source, but here the resistance is present. So in that case, what is the value of AV? How to calculate the AV? I think we have in the previous class also we have solved this type of problem. Tell me what is the value of AV?
It looks like 50 divided by 50 plus 1 into 5 minus V in.
What is the formula for AV when a resistance is there in the source side? Have you remember
minus
this RDY?
minus GM into
No, no, no. If there is a yes, AV equal to GMRT, this is for another circuit. Okay, when there is a resistance is present in the source side, like degenerative type of circuit, in that case the value is RD by 1 plus GM. Like this is called RS. The RS resistance is there. This is the RL and this is the RD. So when this type of circuit is there, now the RS is present. In that case, the value of mod of AV is 1 by RD by 1 by GM plus RS. But here in the drain side, both resistance is in the parallel position. So here in our case, the RD is parallel with the RL, then 1 by GM plus RS. Now calculate the value of mod of AV. RD parallel with RL by
ma'am
1
native
by
gain, ma'am.
GM plus RS. Yes.
In common source, the gain should be negative.
See the magnitude value we are taking, right? Mod of AV. So when you are taking the mod of some negative value, so it should be positive. So just neglect the sign. Just calculate the value. So RD value is given, RL value is given, RS value is also given. So we have to find out the value of GM, right? So what is the value of GM, Pradeep?
Under root of 2 ID into mu and C1.
GM is root over twice of ID mu n cox w by L.
W by L.
Yes. So now tell me what is the value of GM.
2ID.
At first, tell me what is the value of ID here, because we are taking like the half symmetry portion. Okay. So it is the value of current from which is flowing from this side. Tell me what is the, if it is half symmetry, then how much current is flowing from this side? What is the value of ID in this case, like this circuit?
5 divided by 5K.
No, that here you can see now the total current which is flowing from this circuit is 0.8 milliamps. So from this side and this side, how much current is flowing? 0.8 by 2, na? Hello.
0.8 where it is flowing, madam?
Here you can see. Here.
Okay.
So here half current will flowing, and from this part is the half is flowing, right? So
Okay,
from
okay.
this side, the current is 0.8 by 2. Okay, so
Ah,
the current here flowing 0.4 milliamps. So here
okay.
just you have to put the value of ID. So ID
2
is
into
0.4
0.4 milliamp
milliamps.
into 10 power minus 3.
Just put the value. I think all of these are in milliamps, so there is no need to put. Mu and Cox W by L value is 4, right? 4
Ma'am, will you
milliamps.
please repeat calculating of ID current?
Uh, Sorry, can
Minus
you
4 into 4 is 1.6. 10
uh,
power minus 6 becomes 10 power minus 3 outside.
the previous one you are telling something now? How to calculate which one? Which
ID, ma'am,
calculation?
ID.
ID. See,
ID.
from this is the symmetrical, like if we are taking the equivalent circuit now, this is the symmetrical circuit, half symmetry we can tell. So from the total circuit, the current is flowing 0.8 milliamps. So half of the current flowing from this side and half of the current is flowing from this side. So 0.8 is total. So half is 0.4. So this side 0.4 milliamps current is flowing. So now we are just taking the half of the circuit like this one. Okay, so the
Ma'am,
zero point
can
0.4
you
current is, yes.
can you tell that MOSFET is
1 by
in which
5 1
region,
by
ma'am?
5.
That means either in saturation or in trial region.
At first tell me in which condition the MOSFET will saturation on, and which condition it is in linear.
If VDS is greater than VDS hat, then it is in
Yes,
saturation.
but here you tell me, just you have to find out the value of ID where the total current is given, and it is half symmetry. So half of the current flowing from this side, it is already given that 0.4 milliamps, okay, flowing from this side. So there is any need that it is in saturation or it is in linear, because the current is given
No,
now.
ma'am.
You are just
Actually, I
have
am
to put.
asking. Just I want to know this type of circuits. How to discuss about the which type of region, in which region the MOSFET is in. I want to know.
1 by
Like calculating nothing means, ma'am.
Okay, okay,
I want to
you are just
know.
talking about the equation, right? So you have to
As
find
ma'am,
out
means
the value of.
I am not getting before calculating the ID current. I not getting that I have not got the idea that overall current is 0.8 and it is symmetry upon 2 0.4. Man. Actually, according to my academics, Till now, I have calculated ID current using either it is saturation region or in triode region, ma'am.
Okay, okay.
RS.
Okay, here actually in this case now you have to find out the total if is in this circuit the total current flowing from this is 0.8 is given. So here current is given and you can see if we are taking for the small signal analysis and also for the DC signal now. So you are just we can what we have done here, this 10 kilo ohm resistance we have divided in the series condition 5 and 5. So you can see in that case in this side and this side is this look like the same. Okay, so in that case we can take it is a half symmetry and we just taken one part for this side and this side both cases the gain is same. That's why just we have taken one of the part and this is the equivalent equivalent circuit from the left side or right side and we just put all the value like here the 5 kilo ohm resistance and 5 kilo ohm resistance is in the parallel and then the MOSFET is given and this is the 5 here the 50 ohm is and then it is a ground. We are just taking the half circuit, half symmetry circuit. Okay, and now we just have here it is already given the total current flowing from this two now this is symmetry, so this is 0.8. So in that case there is no need to find out the triode region current or the saturation, just we know that same the circuit is look like same the both sides are the same. So same current flowing from this and the total current from this side is flowing, so half of the current will flow from this side, so this is 0.4. Okay, and also here how we have calculated that in the MOSFET is in saturation or is in linear, VDS is greater than or equal to VGS minus VTH. Here the VGS you tell me the V input one value is given,
Yes, ma'am.
how we will calculate the VGS. So that's why we are finding some easiest way how to calculate this ID. Okay, so you can see in the question also when we have to find out from the triode or the saturation region VGS must be given. Okay, so there is some clue to find out this type of problem. VGS or given or the V input something is given, so we can find out from this portion how much current is coming. So in that case it is if it is satisfying this condition now we can then we can tell it is in saturation. Okay, but here you can see
Yes,
the
ma'am.
V now not the V input 1 and not the V input 2 is given. So in that case how we will calculate the it is in triode or in the saturation region or how to calculate the ID. So in that case we can see here the total the both sides is look like same. So we can this is the equivalent circuit and this is the so this look like a half symmetry and we are taking one part this left side or the right side it's look like this, and in that case total current is following this, so half of half it is divided, so the 0.4 milliamps current is flowing from this side. So just put this value here and we can get the value of gm and then just put the value of gm in this equation. And the AV what you have told minus of something, so when you have used this mod so you are taking the
Yes, ma'am.
magnitude, so in that case there is no need to write the minus because minus of mod something it will be positive.
Ma'am,
Okay,
will you please explain what is the role of negative sign in the gain, ma'am? Means like
negative
our
sign means just 180-degree phase shift.
means
Negative sign means 180-degree phase shift. There is a phase difference, na? We are like tell me if the current is flowing from this side to this side, we are writing one, and if the current is flowing from the opposite direction in particular something we are taking in a circuit this side. So in that case, how we write like minus I, right? Why we are taking because the direction is changing or we can say so like that. Here is also when there is a phase shift in 180-degree, in that case we write it as a minus. Okay, and when we are taking some minus sign of magnitude of this minus sign it can be written directly one, that's why we are taking the magnitude. So there is no need to write minus or plus. Okay. And why we are using this formula? Because when in the source side any resistance is there, you can see the direct formula, that is Rd by 1 by Gm plus Rs. So you can just but here in the Rd side you can see the Rl is, it is in also the parallel condition with Rd. That's why Rd parallel with Rl by 1 by Gm Rs. Now calculate the value of Gm. Just a minute. What is the value of Gm? Now I'm going to erase it.
1.7.
And then calculate the value of 1 by Gm.
Madam, I also got 1.78 and value of 1 by GM
Yes. Just put the
is
value of 1 by Gm in this equation.
0.559. Madam,
0.56.
final answer I will tell you. Mod of
Yes.
AV I have got 49.44.
Just a minute. And any of you have calculated and you're getting the same answer?
47.
So what is the
49.44.
value of Gm?
GM is 10 power 3 root of 3.2, which is
Root over
1.788.
3.2, 1.789 milliamps per voltage.
Yes.
Okay. And what is the value of Gm? 1 by Gm?
0.56.
0.559.
559
0.56, ma'am.
ohm. Can we write like this? 0.5 now. So
Yes,
this
ma'am.
is in
Yes,
kilo
ma'am. Yes,
ohm.
ma'am.
So 1
Right,
by
right, ma'am.
Gm. So just put the value here. So Rd parallel with RL. What is the value of it? 5 kilo ohm parallel with 5 kilo ohm. Tell me, what is
5
the
kilo
value
ohm.
of it? 5
2.5.
by 5 plus 5. Okay. So what is the value of
2.5.
it? 2.5. 2.5. And below 559 plus, what is the value of RS? 50.
50.
50. Now tell me what is the value of AB. I think 2.5 is kilo. Okay. Just see the unit, and this is in ohm. Now tell me the value.
559. 9. 0. 0. 9.
Just 2.5 kilo ohm, and below side 559 plus 50, 50 ohm, I think. Yes. You can convert in one unit, like kilo ohm, you can convert it in the ohm, or ohm, you can convert it in the kilo ohm. And then tell me what is the right answer.
4.105.
An unit?
No
Unit is
units, madam.
No
no
units, ma'am.
unit.
No units per
Yes,
gain,
yes,
ma'am.
yes. Yes. So the right answer is 4.1.
No, actually, the other student, I wanted to tell him that this entire derivation was simplified because of Miller's theorem. It is one of the theorems in network analysis, and it clearly states that if an impedance is connected between the input and output nodes in an amplifier, having a reference node n, then this impedance can be replaced by two impedances, one connected between the input and the reference node, and the other connected between the output and the reference node. That is why I told madam also that if we are going to have another ground on the top, then we can make it as a partition on the reference of making it as a uh, dual.
The half symmetry circuit.
Yes, half symmetry.
Okay, so we can move toward the next question. So this is the simple question. So for the given NMOS amplifier, the intrinsic gain mod of A0 is given is 80 at 100 microamps. If the bias current is reduced to 25 microamps, then the intrinsic gain will be. At least tell me what is the value of A0. What
This
is the
is
value of
80,
gain?
80 given.
No, the formula of gain, intrinsic gain.
GM into
Output by
RD, madam. GM into RD.
Yeah, intrinsic gain. Okay, so for the MOSFET intrinsic gain, it is GM into R naught.
R not. Yes, yes.
Okay, and it is given. So, and we know that the value of GM is, tell me the equation.
Root O 2 ID,
Output 2
mu n
into
PR.
ID mu into COX W by
WL.
L.
Now tell me what is the equation or the value of R naught
1 by lambda ID.
1 by lambda ID,
by
ma'am.
lambda ID. Now tell me the value of mod of 0, A0. What is the value? Can we write like this? GM
S
value
2
ID
ID
mu
mu
n
n
COX
PR W by L
W by L
by
into
lambda ID by lambda ID.
by 1 by into 1 by lambda ID.
ID.
Now tell me what is the relation between this A naught and this ID?
Proportional to root over 2
Inversely
ID.
proportional.
Yes, inversely
Yes, yes,
proportional to root of ID. So we
yes,
can
yes.
write
Root of ID, ma'am.
in proportional to 1 by root of ID. Can we write like this?
Yes,
Correct,
yes.
correct.
Okay. So for the K01, we are taking that the, 1 means the first case, the ID will be ID1. And for the second case, A02, it is ID2. Now tell me if we are like for the first case, if we are considering A naught, it is 80, for current is 100, and in this case, ID is 25. We have to find out the A02, right? So how we will write down the formula? Tell me.
160, ma'am.
25 by 100
Yeah,
into 80.
A02 by A01
1
and
equals to under
equal
root
to
of
ID.
ID
2.
1.
Yes,
100
ID1 na. We
Yes,
are
yes, sir.
taking A02 by A01 and it is inversely proportional by
Under root of ID 2.
ID2. Now tell me what is the value of A0.
2, 2, 2,
160, 160, ma'am.
2
Yes,
into 80,
A02 value
160.
is
160.
root over 2. What is the value of ID1? ID1
100,
is
20,
100
100,
and
10,
100,
10
ID2
by
is
5, 10 by 5.
25
25.
and it is 80.
25.
So 2
2
into
into
80.
80.
And
So it is
160.
160. So the right answer is, and this is mod value, magnitude we are taking. Okay. So today up to this, so next we will meet again the next Tuesday 7 to 9 p.m. Okay, you can leave.
Ma'am, a small question from my
Yes. See,
uh,
if we are facing, if we are facing any issue or something, you want to discuss now. So, if previously you can mail me. So, in the next session also we can put 2 3 question like that. So it will be resolved. Yes, tell me.
Till now I have seen two types of circuits for common mode, common drain and common source, ma'am.
Hmm.
The two circuits are like one circuit is voltage divider, ma'am, and the circuit is not like voltage divider. Which is more efficient according to you, ma'am? Means which type of circuit is more efficient?
Actually, I think it is based on the application where you are going to apply this type of circuit. You can go through the application of this type of circuit. It will be more easy. Or
Means gain is approximately equal for both the circuits, ma'am.
okay,
The
Pradeep,
main thing that
do
we
you
are
have any
discussing
idea
while
if the gain is equal for both circuit? Then how you will find out that this type of circuit is more efficient, like it is voltage divider? What is the question?
Cross check the impedances, madam. Then obviously application will target for based on the impedance matching also we have to check.
Okay. And any other way to find out which circuit is better for which case?
Check for the current gain also.
So in which cases we are getting the more power, or sorry, more current gain? In that case, it is more useful. Anyone?
Madam, previously, no, madam, according to my experience,
Hmm.
we used to have monolithic ICs. For everything, we had to specifically see the specifications of the sheets, data sheets, and tell them this is the efficient one based on application, etc. But
Hmm.
nowadays, due to advancements in VLSI, nanotechnology, and all that, I have even seen some ICs inside metro train in Bangalore that are operating at a very high current, 10,000 volt, 40,000 volt, etc. So I cannot say particularly that this particular circuit is going to become efficient for a particular application. It depends
Okay.
upon the technology, how it is implemented inside IC.
Okay. And his question is the gain is same for the both cases. Then how we will decide that this
I
circuit?
think so, ma'am.
Yes.
See, gain
I
is
think so. The gain.
Yes. Tell me the question.
Can you repeat the question?
Hello.
Yeah,
Yes. Can you repeat the question?
ma'am. For the circuits, all the circuits, some common drain, common source, and different type of circuits. I have seen two types of circuits, ma'am. One is from using voltage divider bias, and
Hmm.
another is not like a voltage divider. Calculating all the input impedance, output impedance, and voltage gain. Actually, these three parameters we are going to calculate. Getting approximately equal, not exactly equal. I think so. Uh,
Hmm.
Going to the applications, which type of circuit is more efficient, ma'am? I am asking that.
Okay. Now, can you explain, Pradeep or Srikant?
the gain factor doesn't matter these days, sir. But
Because
they
we
are
are,
the different types of circuits.
yes.
Because no, you see, if I use audio systems, there should be high input to drive a large current. But these days, no, even low input is fine because large currents can be driven based on the IC's implementation also. We don't know how the internal VLSI circuit implementation is. There might be wires inside VLSI that can actually drive large currents than the circuit capacitances also, because these days no leakage capacitances can go as low as 0 microamp. So we cannot tell that.
We can directly cannot tell that, but his question like that, it is almost same, but how we find that which is more efficient, like which circuit?
This circuit cannot be said that it is efficient for a particular application unless we use it. Of course, I told no. If there are high impedances which have to be driven like speaker or some kind of a high resistance device, maybe it is not related to microelectronics like microscope or AFM, atomic microscope and all. That time we can obviously go for common drain circuits, and that too that are implemented with not the voltage divider but the other one.
So we cannot directly say that this circuit is better when you are using the voltage divider or not the or doing the simple way, right?
Yes,
Okay.
madam. Yes, madam.
Yes.
Thank you.
Okay. Okay.